Okay, so today we're going to be going over the first derivative test. So our objective by the end of today is to be able to determine the intervals on which a function is increasing or decreasing, and based upon that, where we have relative extrema. So first, what is our definition of increasing and decreasing? A function is increasing, ignore that. A function is increasing anytime as the x values get larger, so do the y values. So the y value to the left is smaller to the y value to the right, therefore the function's increasing. So that is drawn on the right side of our graph here. A function is decreasing if the y values get smaller from left to right. So that's drawn by example over here. And if the y values are exactly the same, we say that's constant. Okay, remember to read your graph from left to right. All right, so how do we test for increasing and decreasing? Well, we say that if f is continuous on AB, so notice it's continuous on the closed interval and differentiable on the open interval. So notice these conditions tend to hold true for pretty much every function we do in calculus. We're looking for continuous on the closed interval, differentiable on the open. If f prime of x is greater than 0, so if it's positive, well, positive and derivative is slope, so positive slope means the function is increasing. If f prime of x is less than 0, that means that it's negative. The slope is negative. If the slopes are negative, then we say the function is decreasing. And if the derivative is 0, we say the function is constant. Oops. So, guidelines for determining increasing or decreasing. You want to find all your critical numbers and make yourself test intervals based upon that. So remember that critical numbers are where your derivative is equal to 0 or where your derivative does not exist. You want to pick a value in the interval and plug it into the derivative to figure out if the derivative is positive or negative there. So I create intervals based upon in between my critical numbers. Also, my endpoints could be included in that. And I pick a value in those intervals. So it can be any value in that interval. So my test value might be different than your test value, might be different than your neighbor's test value, as long as it's in the interval. So you plug it in. I don't really care what f prime of x is. I only care about the sign of it. So if I'm getting some huge massive number, but I know it's positive, then all I care about is it's positive. Now, if it's positive, I'm going to state it's increasing. If it's negative, I'm going to state it's decreasing. If it's 0, then I did my intervals wrong because my intervals should be created by where it's 0. If a function, if you plug in all the values and everywhere you find that it's increasing, then we say it's strictly monotonic. If I plug in values and I find that it's always negative, then I say it's strictly monotonic. Okay, so strictly monotonic means it's always increasing or always decreasing. So we're going to find the intervals on which this function is increasing or decreasing. So I'm going to start by taking the derivative. So f prime of x is, I bring down the exponent, so I get 3, and then I subtract 1, so x squared. I bring down the exponent of 2, and so I subtract 1, so that becomes x. So I end up with 3x squared minus 3x. Now, this is a polynomial, and so polynomials always exist. So there's never going to be a DNE for f prime of x. So now I find where does that equal 0. So 0 equals 3x squared minus 3x. I'm going to factor it. So I'm going to factor out a 3x, and I'm left with x minus 1. So then 3x has to equal 0, or x minus 1 has to equal 0. So then x would be 0 or x equals 1. These are my critical numbers. Now, to create my intervals, I also have to look at what's my domain? So I wasn't given a closed interval. I was given a polynomial. The domain of a polynomial is negative infinity to infinity. So I'm going to create intervals in this domain that stop at each critical number. So my first interval is going to start at negative infinity, and it's going to continue until my first critical number of 0. Then from 0, I'm going to continue until my next critical number of 1. From 1, I'm going to continue until my next critical value, which happens to be my domain of infinity. So on this one, I don't need that last column. I only need 3 columns this time. So now I need to pick a number between negative infinity and 0 to plug into f prime of x. Pick something nice. Don't pick negative 153. You're going to have a hard time calculating that. Pick something nice, maybe like negative 1. Between 0 and 1, maybe I want to pick 1/2. You can pick something else as well. Between 1 and infinity, maybe I'm going to pick 2. These are not the only values you can pick, but they are just examples. So now I need to find the sign of f prime of x. So I'm going to find what is f prime of negative 1. And so I go do 3 times negative 1 squared minus 3 times negative 1. I end up with, let's see, negative 1 squared is positive, so I end up with 3. Negative times a negative is a positive, so I end up with 3 plus 3. That is positive. I don't care what number it is. I might be able to find that number, but I don't care what it is. All I care is that it's positive. Since it's positive, my conclusion is that it is increasing on this interval. Okay, now I do the same with 1/2. So I get 3 times 1/2 squared minus 3 times 1/2. 1/2 squared is 1/4. So I end up with 3/4 minus 3/2. So 3/2 is bigger than 3/4. So since that's bigger, this is a negative number. So now I could say it's decreasing here. And then with 1 to infinity, I'm going to plug in 2. So I get 2 squared minus 3 times 2. So that's 4. 2 squared is 4. 3 times 4 is 12. 12 minus 6 is positive. So now it's increasing again. So I have something where my graph is going up, then it goes down, then it goes up again. All right. So far what I can say is that it's increasing on the interval negative infinity to 0. It's decreasing on the interval 0 to 1. And it's increasing on the interval 1 to infinity. So you guys should try the next one. And so I would hit pause, try the next one, and then when you're ready, hit play again to check your work. Okay, so you should be trying this problem. I'm going to give it a minute and then I'll check it with you.
You have to do Excel process. You're not going to be able to do that first time answer for like.
Okay, so to check our answers, if you haven't finished yet, again, hit pause. Otherwise, start by taking the derivative. So f prime of x is 4x cubed minus 16x. So we want to figure out, where is this d/e? Well, it's a polynomial, so it's not going to d/e. So then where is this 0? And so I'm going to factor out a 4x, and that leaves me with x squared minus 4. So 4x could equal 0, or x squared minus 4 could equal 0. So x could be 0, x squared could be 4, x could be plus or minus 2.
Does not exist.
So I go from negative infinity to negative 2, from negative 2 to 0, from 0 to 2, and from 2 to infinity. So notice overall, all my intervals put together end up matching the domain of my function. And I do need to make sure I do my critical numbers from least to greatest. So now pick a test number within each interval. While your test number may be different from mine, your sign of f prime of x must end up being the same. All right, so I'm plugging into f prime of x. Now, what I prefer to do is plug into that factored form is actually going to help you out sometimes. So I'll plug into that factored form of it. So I get negative 12 times 9 minus 4 is 5. So a negative times a positive is a negative. Therefore, I know my function is decreasing. I plug in negative 1. I get 4 times negative 1. So I get a negative times negative 1 squared minus 4. So I have a negative times a negative. That's negative 4 times negative 3. So that's a positive. Therefore, my function is increasing on this interval. Okay, I plug in 1. So now I get 4 times 1, 1 squared minus 4. So I get 4 times negative 3 is a negative. So it's decreasing on this interval. And then I plug in 3. So I get 4 times 3, 3 squared minus 4. I have a positive 12 times a positive 5. That's a positive. So it's increasing. So it's decreasing on the first interval, increasing on the next, decreasing on the next, increasing on the next. All right, so this leads us into the first derivative test. The first derivative test tells me that if c is a critical number that is continuous on an interval containing c and differentiable on the interval except maybe c, because remember that some of the ways we find critical numbers is where the derivative does not exist, then f of c can be classified based upon the following rules. If f prime of x changes from negative to positive, so if the sign of f prime of x changes from negative to positive, that means the function itself is changing from decreasing to increasing, then the function has a relative minimum. And so if you graph that, you're going from negative to positive. Notice it creates that kind of that valley, so that relative minimum. And so we say it has a minimum at c with a value of f of c. If it goes from positive to negative, it's creating that hill, so we say it has a relative maximum. And if it doesn't change, so if it goes from increasing to increasing, or if it goes from decreasing to decreasing, then we say that it doesn't have a max and it doesn't have a min. So basically we found no new information there. So let's actually start classifying. We're going to find the relative extrema of 4 cosine of 3/2 x in the interval 0 to 2 pi. So this time when I create my intervals, it's going to start at 0 and it's going to end at 2 pi, not from negative infinity to infinity. So I'm going to start by taking the derivative. So the derivative of cosine is negative sine. So I'm going to write that as negative 4 sine. But notice inside my function, that's not x. That's 3/2 x. So I have to apply chain rule. The derivative of 3/2 x is 3/2. So negative 4 times 3/2 is negative 6. I get negative 6 sine of 3/2 x. Now, sine is continuous, so there's never anywhere that it's going to DNE, but it can equal 0. So I'm going to set it equal to 0. I divide by -6 and I get 0 equals sine of 3/2 x. So I'm going to ask, where is sine 0? So that means 3/2 x could equal, let's see, sine is 0 at 0. 3/2 x could be sine is 0 at pi. And then I might need to keep going. We'll have to see. So that could be at 2 pi. And I'm going to wait to see, maybe I have to keep going. So I'll start multiplying through by that 2/3. To get x by itself, I multiply by 2/3. So x equals 0. I multiply by 2/3. X equals 2 pi over 3. I multiply by 2/3. X equals 4 pi over 3. So notice I'm still within my domain. So I'm going to go a little further. So now I'm going to say that 3/2 x. Let's see. The next place sign would have been 0, would have been 3 pi. So I'll multiply that by 2/3 because the reciprocal of my fraction. So x is, okay, now I've hit an endpoint. 2 pi is an endpoint. So now I've gotten my full domain and my critical numbers within it. Technically here, the only critical numbers are 2 pi over 3 and 4 pi over 3 because they are inside my domain. And so my interval starts from the left end of my domain and it goes until my first critical number. Then I go from that critical number until my next critical number. I go from that critical number until my other endpoint. And so now I need to pick values within these. Pick values that are nice to plug in. So, and you're going to want things that work out nicely on your unit circle. So let's see, let's put in pi over 3 might be nice here. This one, if I plugged in pi is in between those guys. And if this one, I'm going to put in 5 pi over 3. And the reason I picked the pi over 3s is to help out on the fractions a little bit. So I'm going to get the sine of f prime of 6 is -6 sine of 3/2 times pi over 3. So that's a 3 over 2. If you can't read, my 2 looks bad. The 3's cancel. And then so I get -6. And then sine of pi over 3. Well, pi over 3 is in the first quadrant. And in the first quadrant, sine is positive. So you don't even need to know the value. You just need to know that sine's positive there. Because a negative times a positive is a negative. So it's decreasing here. If I plug in pi, I have -6 sine of 3 pi over 2. At 3 pi over 2, that's down below. So I get -6 times a negative. 2 negatives make a positive, so it's increasing. -6 sine of 3/2 times 5 pi over 3. So that ends up 5 pi over 2. And so, oh, by the way, on this first one, I was saying pi over 3, but that's pi over 2. So on this one, that's sine of pi over 2, which is still positive. It's that boundary of the first quadrant, which is still positive. Now, 5 pi over 2, if I'm going around my unit circle, so up top is 1 pi over 2. And as I go around, I get 2 pi over 2, then 3 pi over 2 is down below. 2 pi is 4 pi over 2, so 5 pi over 2 brings me back to the top. So since that's on the top, that's positive. So I get -6 times a positive is a negative. So that's decreasing here. And then that's it. That's all my intervals. So as I'm doing this, I now can work on making conclusions. So I go from decreasing to increasing at 2 pi over 3. Therefore, at 2 pi over 3, I have a relative minimum. At 4 pi over 3, I go from increasing to decreasing. So I'm making that hill there. So I have a relative maximum at 4 pi over 3. I can't say anything about absolutes unless I plug in at each of them, including the endpoints. But I can state that there are relatives based upon the first derivative test. So on the next slide, I'll go ahead and write these conclusions. Since f prime of 2 pi over 3 actually, let's change that. Two pi over 3 is a relative minimum because f prime of x changes from positive to negative. Or sorry, negative to positive. It was negative first. Order does matter in this. So it was negative, then it went positive. If I'm talking about f prime of x, I'm going to talk directly about its sign. It goes from negative to positive. I could also say this statement that it's a relative minimum because f of x changes from, and then talk about the rate of f of x. So I could say f of x changes from decreasing to increasing. So I could use that language as well. But if I'm going to state the derivative, then I have to directly talk about its sign. If I said f prime of x is decreasing, that would actually be talking about acceleration. It would be talking about the second derivative. And then so my other statement is that 4 pi over 3 is a relative max. And so this statement's basically going to be flipped because f prime of x changes from positive to negative. I would encourage you to type this original f of x into your graphing calculator and actually see if the max and mins happen at these values. So use your values to see if that works. All right. And then we can also go over using the graphing calculator on Thursday. Okay, so now on this one, we want to find the relative extrema. And these examples are different than the ones in your book, so feel free to look at your book for more examples. So I'm going to find f prime of x. So I'm going to bring down that exponent, and I'm going to subtract 1. So 2/5 minus 1 is negative 3/5. So I'm going to rewrite this. That negative term is going to go in the denominator, that negative exponent, I mean. So that's x to the 4th minus 1 to the 3/5. So this can never equal 0. There's no variable in the numerator, so this can never equal 0. So what I'm going to do is I'm going to see where it DNEs. F prime of x DNEs when the denominator is 0. So then I'm going to say just to the power. To get rid of the power, I'm going to multiply both, or not, I'm going to raise both sides to the 5/3. But 0 to the 5/3 is still 0. So I'm going to do add 1. So 1 equals x to the 4th. And so you're going to take the 4th root, but anytime you take an even root, remember to do plus or minus. So the 4th root of 1 is just 1. So I have critical numbers at plus or minus 1. So my interval goes from negative infinity to -1, from -1 to +1, and from +1 until infinity. All right. And so now pick some test values, so maybe -2, 0, and 2. And I'm going to plug these into f prime of x. So on top, I'm always going to have a negative. And on the bottom, so I have -2 to the 4th minus 1 to the 3/5. Remember, I don't really care about the value, just if it's positive or negative. -2 to the 4th is something positive that's bigger than 1. So therefore, that's positive times 5 is positive. So I have a negative on top of a positive. So I have a negative over a positive, which means it's negative. So it's decreasing here. If I plug in 0, I get 0 to the 4th minus 1 to the 3/5. -1 to power, an odd power, well, that's still negative. So I get a negative over a negative. So that's going to be a positive. So it's increasing here. Okay, I put in 2. So I have 2 to the 4th minus 1 to the 3/5. Well, that's something positive. So I get a negative over a positive is a negative. Therefore, it's decreasing. So now I can say that there is a relative okay, so what always helps me is I like the visual. So decreasing looks like a line going down, increasing is going up. So that's a relative minimum. It's a relative minimum at -1. And then it's a relative maximum at +1. So I'd write the statement that at -1 is a relative minimum because f prime of x changes from negative to positive. I would say at 1 is a relative maximum because f prime of x changes from positive to negative. All right. Okay, one last example. So this one, a couple things. One, notice that 1 and -1 are not in my domain. Okay, so x cannot equal plus or minus 1. The reason is those are the values that make my denominator 0. Those values make my denominator 0. So I'm going to find f prime of x right now. And so I have O over P. So I get P O prime minus O P prime all over P squared. Okay, well, right now, I can tell you that my derivative will dne when x squared minus 1 equals 0. So that's x squared equals 1, x equals plus or minus 1. So plus or minus 1 end up being critical numbers because something's happening on the graph. And that's something, the derivative doesn't exist there. The derivative is going to equal 0 when the numerator is 0. So I'm going to set the numerator equal to 0. I could set the whole thing equal to 0, but I'm going to have to multiply by the denominator, and it's going to go away anyways. So I'm going to go ahead and distribute. I have 4x to the 5th. I add those exponents. And then I have minus 4x cubed minus 2x to the 5th because I add those exponents. So I have 0 equals 2x to the 5th minus 4x cubed. So 0 equals 2x cubed And what's left behind is x squared minus, and when that just leaves me with 2. So then I get that 2x cubed equals 0. So x equals 0. And I get that x squared minus 2 equals 0. So x equals plus or minus the square root of 2. That's fun. All right, so the square root of 2 is it's approximately 1 point something. Let's see. So let's see. The square root of 2 is approximately 1.4. So just a heads up on that. So I'm going to go from negative infinity until negative root 2. From negative root 2 until negative 1. From negative 1 until 0. From 0 until root 2. From root 2, wait, nope. From 0 to 1. From 1 until root 2. And from root 2 until infinity. So this might be one where, guys, as a class, divide and conquer to finish this problem. All right, I'm going to do test values. And I'm going to use factored form to help me out with that test values. So this one, I'm going to use negative 2, negative 1.1, negative 0.5, 0.5, 1.1, 2. So I'm going to figure out the signs, and so I'm going to get 2 times a negative cubed. I don't really care what that number is. I just know that's a negative cubed is negative. Negative 2 squared minus 2, that's going to be positive. So I have a negative times a positive is a negative. Decreasing. I'm going to do, that's 2 times a negative, so that negative cubed is still a negative. 1.1 squared is going to be 1.21, which minus 2 is negative. So those negatives become a positive. That's increasing. And this one, just a heads up, this one's like a worst case scenario. Though on the actual AP exam, you'll never have first derivative test with more than 3 or 4 intervals at a worst case scenario. All right, negative 0.5. I still have a negative in front, so 2 times a negative is a negative. If I put in 0.5 squared, that's 0.25. Minus 2 is still negative, so that's a positive. So it's still increasing. So notice here's an example where it doesn't change, which kind of makes sense because negative 1 wasn't in my domain. So something else is happening there, not a relative max or min. If I plug in 0.5, now I have a positive in front, but I have a negative in there. So that's decreasing now. I have a 1.1 is a positive in front. When I plug it into x squared minus 2, I get a negative. So it's still decreasing. And then when I plug in 2, I get positive. And then 2 squared minus 2 is a positive. So that's a positive. So it's increasing. So if I was to make statements here, I would say that there is a relative minimum at negative square root of 2. Then I don't say anything about negative 1. But then at 0, there is a relative maximum because f prime of x changes from positive to negative. Nothing happens at 1. But at root 2, I would say there is a relative minimum.